Hey, I'm Mitchell. Welcome to another video in the RSP Education series. In industrial automation, protecting motors goes beyond just using a standard circuit breaker. Motors have unique electrical demands, from high inrush currents to continuous load variations, and this requires specialized protection. In this video, we're going to break down motor protection circuit breakers, or MPCBs, how they prevent overloads, short circuits, and motor burnout. We're also going to cover smart circuit breakers, which bring real-time monitoring, remote control, and predictive maintenance to modern industrial systems. If you like this kind of content and want more educational videos, like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So, motor protection circuit breakers. In industrial automation, MPCBs are specialized devices that are designed to safeguard electric motors, which are critical components in many industrial processes. Here's a breakdown of their functionality and an importance at a mid-range level. Purpose-built for motor loads. MPCBs are specifically engineered to handle the unique characteristics of motor loads, like high inrush currents during startup and continuous operation under varying loads. Unlike standard circuit breakers, MPCBs account for the thermal and magnetic stresses that motors experience. Dual protection functions. So there's short circuit protection. Motor protection circuit breakers detect and interrupt high magnitude fault currents that are caused by short circuits, and this prevents damage to the motor and its associated wiring. They boast overload protection because motors can overheat due to prolonged overcurrent conditions, like mechanical overloads or locked rotors. MPCBs monitor the current and trip it if it exceeds a safe threshold for a specified time. This protects the motor from thermal damage. So, selective coordination with contactors. Motor protection circuit breakers are designed to work seamlessly with contactors, or motor starters, and control circuits. Selective coordination ensures that only the faulty circuit is isolated during a fault, while other parts of the system remain operational. This eliminates disruption to the overall automation process. Adjustable settings. Motor protection circuit breakers often feature adjustable current and trip settings. This allows them to be fine-tuned to the specific motor's rated current and operational requirements. This makes sure that there's precise protection without unnecessary nuisance tripping. They prevent motor burnout. So by combining short circuit and overload protection, MPCBs prevent motor burnout, which can result from electrical faults or excessive mechanical loads. This extends, in turn, the motor's lifespan and reduces downtime. So in summary, motor protection circuit breakers are critical components in industrial automation, providing robust protection for motors specifically by addressing both short circuit and overload conditions. They enhance system reliability, they prevent equipment damage, and they ensure efficient operation of motor-driven processes. On the other hand, we have electronic or smart circuit breakers. These are automation-ready breakers for smart industrial systems. Let's talk about where they're used. You'll see them in smart grids, SCADA systems, industrial automation networks. You'll see them in critical infrastructures like data centers, hospitals, renewable energy plants. You'll see them in high reliability applications that require continuous monitoring. Some key features and why these smart breakers stand out: because of their real-time monitoring and diagnostics. So unlike traditional breakers, smart breakers provide continuous data on voltage, current, and power quality. They detect faults, overloads, and anomalies in real time, and this reduces downtime. They integrate very well with industrial control systems. They communicate with SCADA, or supervisory control and data acquisition systems, PLCs, or programmable logic controllers, and industrial Internet of Things networks. They allow automated decision-making based on live system conditions. Some other strengths of smart circuit breakers are its remote control and predictive maintenance. Operators can trip or reset or adjust breakers remotely. This reduces manual intervention. Some advanced models support AI-driven predictive maintenance, and this prevents failures before they even happen. Imagine that. Energy efficiency and load management. So this helps optimize power usage by identifying inefficient loads, ideal for facilities aiming to reduce energy costs and comply with sustainability initiatives. Let's summarize. Monitoring and data logging through real-time remote diagnostics. Integration with SCADA, PLCs, IoT, smart grids, you name it. Remote control for tripping and resetting remotely. Predictive maintenance insight through AI-based alerts and fault history. Energy management through load balancing and power tracking efficiency. Why circuit breakers matter in industrial automation. Overall, they prevent equipment downtime. A fast tripping breaker is going to protect automation systems from prolonged damage, and this reduces unexpected production halts. It also enhances safety. Properly rated breakers prevent electrical fires, shocks, and catastrophic failures in industrial facilities. There's improved selective coordination. Circuit breakers with adjustable settings allow for better fault isolation in complex automation systems. This allows for only the faulty section trips to be tripped, not the entire line. Support predictive maintenance. Modern breakers with Internet of Things integration provide real-time data. This allows engineers to predict failures before they occur. In conclusion, in industrial automation, circuit breakers are not just protective devices. They're critical components that ensure the reliability, efficiency, and safety of automated processes. Selecting the right breaker for each application, from PLC panels to MCCs, motor control centers, helps mitigate risks, reduce downtime, and optimize operational performance. We've covered a lot in this video and in this whole series on circuit breakers, honestly. Breaking down the role of motor protection circuit breakers, or MPCBs, and smart circuit breakers in industrial automation. Understanding how these breakers function helps keep your equipment running efficiently, minimizing downtime, and ensuring safety across your operations. For a full line of motor protection circuit breakers and smart circuit breakers, as well as hundreds of thousands of other industrial automation products, go to our website at rspsupply.com, the internet's top source for industrial hardware.